Hi guys, I hope you are all doing well. Let's see today's question. So today's question, it is given to us that a determinant of four elements, that is in a 2 by 2 form, is given to us as equal to 0, and the four elements are summation of k equals to 0 to n k, summation of k equals to 0 to n nCk into k square. Third element is given to us summation k equals to 0 to n nCk into k, and summation of k equals to 0 to n nCk, and this is given as 3 raised to k. So the determinant of this four elements that is given to us is equal to 0. We need to find the value of summation of k equals to 0 to n nCk upon k plus 1. And it is also given to us that this is equal to 0. It is true for some positive integer n. So n, basically it is given to us that it has to be a positive integer. So let's first try to find the value for n, and whatever value of n we get here, we'll substitute it in the question asked, right? So first, if I try to find the value for this, I'll remove this now because I don't need this for now. So let's try to solve this element or the determinant. Summation of k equals to 0 to n and k means it is nothing but sum of all the elements, right, from 0 to. So from 0 to n, if I find the sum of elements, adding 0 does not make sense. So adding 1 to n, we know sum of all natural numbers, that is given as n into n plus 1 upon 2. So if we know the first element's total sum will be n into n plus 1 upon 2. So here if it is added from 0 to n, it is n into n plus 1 upon 2. Now we know the first element in this case, right? Now let's find the second. It is, if I put n, it is nc0 into 0 square, nc1 into 1 square, nc2 into 2 square, likewise till ncn into n square, right? Third element, if I try to explain it, it becomes nc0 into 1, sorry, 0 into nc1 into 1, nc2 into 2, nc3 into 3, likewise till ncn into n. And the fourth term, it is nc0 into 3 raised to 0 plus nc1 into 3 raised to 1, nc2 into 3 raised to 2, likewise till ncn into 3 raised to n. So let's try to find what are these three elements equal to, and then whatever we get them as, we will substitute in this determinant, equate it with 0, and we'll try to find the value of n, so that further we can find the value for the expression which is asked to us, right? So let's first understand this. So we'll try to solve this, and we will be able to solve this idea using binomial theorem. And binomial theorem, if I tell you, it says a plus b raised to n, I can put it as nc0, a raised to n, b raised to 0. Then what happens is the power of a gets decreased by 1 every successive term, and power of b gets increased in every successive term. So it becomes nc2, a raised to n minus 2, b square. Likewise, till ncn, a raised to 0, b raised to. So now if I write a as 1 and b as x in this same thing, it becomes nc0, 1 raised to n, x raised to 0, nc1, 1 raised to n minus 1, x1, then nc2, 1 raised to n minus 2, x square, and so on till ncn, 1 raised to 0 and x raised to n. Now, if you know 1 raised to anything is always 1, so all the elements which include 1, those are nothing but 1, and multiplied by 1 we get that same respective element. So we do not write it here. nc0 into x raised to 0 plus nc1 into x raised to 1 plus nc2 into x square. This goes on till ncn x raised to n. Now if you compare this entire expression on the right which we got with this element, instead of x we have here 3 for every element. So if I put x as 3, so put x as 3 here, what I get? 1 plus x, or 1 plus 3 raised to n, that is equal to now nc0 3 raised to 0, nc1, 3 raised to 1, nc2, 3 square. This goes on till ncn, 3 raised to n. So basically this entire thing which we had written here, I can write this equal to 4 raised to n, because 1 plus 3 is 4. So the entire expression is 4 raised to n. Now if I want to write it in terms of summation also, I can write it. So this is equal to summation of k equals to 0 to n, nck into 3 raised to k, right? Or I can also write 1 plus x raised to n, that's equal to summation k equals to 0 to n. We got it as nck into x raised to k. Likewise, if I put here x as 3, I got 4 raised to n as k equals to 0 to n, nck into 3 raised to k. So we got one more element. Now let's try to find out the other two remaining elements. So we have found out this, we still need to find this as well as this. So let's try to find them as well. So what I will do is, now I will use the idea which we have written here in terms of x. What I can do here is, I'll remove this for now. So if I have this with me, I can take a differentiation with respect to x. So if I take a differentiation, if I differentiate this particular expression with respect to x, what happens? I get this as n into 1 plus x raised to n minus 1. That's equal to summation k equals to 0 to n, nck. I can write this as k into x raised to k minus 1. So now if you see, the first expression which we had, this, so it tells us nck into k that we need. We have already got nck into k. So if I don't need this idea, I will put x as 1, right? So because 1 raised to anything will make it 1, and multiplying it with 1, we will have this as it is. So if I put x as 1, this becomes 1 plus 1, 2 raised to n minus 1, k equals to 0 to n, nck into k, and this is 1 raised to k minus 1, which will still turn out 1. So I get this as k equals to 0 to n, nck into k, and that is equal to n into 2 raised to n minus 1. So we also get the expression for this, that it is equal to n into 2 raised to n minus 1. Further, let's try to find out the fourth element as well. So now what I will do is, I will differentiate again this expression with respect to x. So what happens is, if I differentiate it with respect to x, it becomes n into n minus 1 into 1 plus x raised to n minus 2. That is equal to summation of k equals to 0 to n, nck into k minus 1 x raised to k minus 2. Again, if I put x as 1, what we get? N minus 1, 2 raised to n minus 2, summation of k equals to 0 to n, nck k square minus k x raised to k minus 2, or is this 1 raised to k minus 2, because we have put x as 1. So 1 into anything, 1 raised to anything is always 1. So multiplying it with 1, we get this same expression left out. So n minus 1, 2 raised to n minus 2, it's equal to summation of k equals to 0 to n, nck k square minus k, right? This I'm not writing it because 1 raised to n is, anything is always 1. So further, if I want to solve this, now I know summation of k equals to 0 to n, nck k square minus nck k. I'm just multiplying k square minus k with nck. So if I multiply, I get n into n minus 1 into 2 raised to n minus 2. So n into n minus 1, 2 raised to n minus 2. Right? Now I have, if I separate this summation on both of the sides, k 0 to n nck into k square minus summation k equals to 0 to n, nCk into k, that's equal to n into n minus 1 into 2 raised to n minus 2. So if I further want to find this out, I already know this idea, right? That's equal to summation of k equals to 0 to n, nCk into k, that is equal to n into 2 raised to n minus 1. So if I write this is n into 2 raised to n minus 1. This is n into n minus 1, 2 raised to n minus 2. And this, if you see, it is summation k equals to 0 to n, nCk into k square. So if I need this, I'll take everything else on the right hand side, that makes it n minus 1, 2 raised to n minus 2 plus n 2 raised to n minus 1. Now let's try to make the same powers of 2. Here I have n minus 2. What I will do is I will multiply and divide by 2 on both sides. So what happens is this becomes n square minus n 2 raised to n minus 2 plus here also if you see 2 and n becomes 2n, and if I use this idea, so it is inverse of 2, that will make it a negative power, so it becomes 2 raised to n minus 2 again, correct? 2 raised to n minus 2, if I take it as common, I have n square minus n plus 2n. So that is n square plus 2n minus n, and that gives us n square plus n. So it becomes n plus 1, 2 raised to n minus 2. So now I have the value for this as well. So now if I apply the determinant which was given to us in the question, the first term we already got, that was n into n plus 1 upon 2. Let's see the second term, what it was. Second term I had was summation of nCk into k square. This we have just got it. It was n into n plus 1 into 2 raised to n minus 2. I can write this as 2 raised to n minus 2. The third term, that was summation of k equals to 0 to n nCk into k. So we already solved for that as well. So summation of k equals to 0 to n nCk into k was n into 2 raised to n minus 1. So it is n into 2 raised to n minus 1. And the fourth term was summation of k equals to 0 to n nCk into 3 raised to k, that was 4 raised to n. So it becomes 4 raised to n. That is equal to given us 0. So it becomes n into n plus 1 upon 2 into 4 raised to n minus n into n plus 1, 2 raised to n minus 2 into n 2 raised to n minus 1. That is equal to 0. Solving it further, let's try to take whatever is common first of all. So n into n plus 1, I can see it is common in both the cases. So I'll take it out common. So we have taken this and this common now. So what I'm left with here is I can write 4 raised to n as 2 raised to 2n. 2 also, if I take it up, it becomes minus 1. So 2 raised to 2n minus 1 is the first expression. Minus. Here, if I solve, n is left out. Apart from that, if I see it, I have 2 raised to 2n because n plus n. So bases are same. I have the powers added. So 2n minus 3. Again, that's equal to 0. So n into n plus 1 was already common. I can still take out 2 raised to 2n minus 1 common again. So 2 raised to 2n minus 1 I can take out common. When I'm taking 2n minus 1 common here, there are two 2's left. That is 2 raised to minus 2 is still left. So I have 1 minus 2 raised to minus 2 n equals to 0. So if I see n into n plus 1, 2 raised to 2n minus 1, and I am left with 1 minus n by 4, that is equal to 0. So what I get is n into n plus 1, 2 raised to 2n minus 1 into 4 minus n is equal to 0. Now here if I see, if I can get n is equal to 0. So this can be equals to 0 or this can be equals to 0. So n plus 1 equals to 0 gives me n as minus 1. I can have 2 raised to something never equals to 0. So the only expression left out here is 4 minus n equals to 0. So here if I solve this, I get n as 4, right? So I have 3 answers for n, but they have said that this is only true for some positive integer n. And when I have the some positive integer as the value of n, I cannot have a negative value as well as 0. So the only possible value is 4. So now if I find out whatever he is asking for, is asking for summation k equals to 0 to n nCk upon k plus 1. I know n is 4 now, so I'll replace n with 4. I get summation of k equals to 0 to 4, 4ck upon k plus 1. So if I put k as 0, it becomes 4c0 upon 0 plus 1, 4c1 upon 1 plus 1, 4c2 upon 2 plus 1, 4c3 upon 3 plus 1, and 4c4 upon 2 plus 1. So what I get here is 4c0 is 1, 1 upon 1, 4c1 is 4, 4 upon 2, 4c2 is 6, 6 upon 3, 4c3 is again 4, 4 upon 4, 4c4 is 1, 1 by 5. So this is 1 plus 2 plus 2 plus 1 plus 0.2. So this comes out to become 2 plus 2, 4, 4 plus 2, 6, and 0.2, so 6.2. So this is what we get here. And if you see the options that matches here is C. So the correct answer in this question is C. I hope you have understood how to solve this type of questions. So whenever this determinants like this expressions are given, you can apply binomial theorem and then differentiate it to get whatever it is asking us. So we can get the answer for this, and then you can put in the values and get the answer for n, and then you can just find out the value for whatever is asking. Like in this case, it was asked to us find the value of nCk upon k plus 1 for sum of k equals to 0 to n. So I'll meet you again tomorrow with the next question. Till then, you can like, share, and subscribe to my videos. And also you can see my previous videos with the previous questions. Thank you.